Welcome back, everyone. So today we'll be going over trigonometric integrals part 2. Let's begin. So with the example we have today, it will be sine to the fourth theta d theta. And one important thing to notice is that the theta is right here. That's just kind of, I want to show you guys that there's a variety of variables I can use. It doesn't always have to be x. And that's why we'll be using theta today. It could be, sine to the fourth W, dw, and we usually use x, but I'll be using theta today, just to switch it up a bit. And we're going to be doing something a little different. We're going to use something called a reduction formula. And this reduction formula goes a little something like this. Negative sine n minus 1 x cos x over n plus n minus 1 over n, the integral of sine n minus 2 dx. And the n is just the power. That's what the n corresponds to. And all we have to do is just plug it into the formula, and it basically breaks down this this integral, and you can solve it as a smaller integral on the right hand side. But one thing to note, this formula is specific for sine. And that's really important because there is one for cosine and another one for tangent. And I can go over that in some other videos, but the one that we're doing right now is specifically for sine. So we wouldn't use this. We wouldn't use it for cosine, or we wouldn't use it for tangent. So all we have to do is just plug it into the formula now. So we're going to have negative sine cubed theta cosine theta all over 4 plus n minus 1, which is 4 minus 1 is 3, and then n is 4, so it'd be 3 over 4, times the integral of sine square theta d theta. So this is the nice thing about using the reduction formula, is that all that we have to solve for now is just this part right here, that sine squared theta. And that's the pretty much kind of like the usefulness of this kind of formula. It just basically breaks down trig functions with high powers down, so we can put it into something simpler. And this is where our trig identities are going to come in handy. So we know that we have sine squared theta and we have cosine squared theta. And these can be rewritten as 1/2 1 minus cosine 2 theta and 1/2 1 plus cosine 2 theta. And these right here are known as the double angle identities. Oops, I spelled that wrong. Identities. So now that they can be written as this, as a double angle identity, if we were to use an integral, we could easily compute that by just distributing the 1/2, and all we would have to compute is basically a cosine function. And that's exactly what we're going to do. So let's bring everything down. Negative sine cubed theta cosine theta all over 4 plus 3 over 4 times the integral of 1 minus cosine 2 theta d theta. Oops, forgot the 1/2 right here. And what we're going to do now is distribute this 1/2 to both. So we'll continue and bring everything down. Negative sine cubed theta cosine theta. And honestly, you don't have to rewrite everything and bring it down every single time, but I just do it for me, so I can show you exactly where I'm at, and so we won't skip a step basically. So 3 over 4 times the integral of 1/2 minus cosine 2 theta over 2 d theta. And now we'll bring it down one more time. Cube theta cosine theta all over 4 plus 3 over 4. And then it'd be 1/2 theta minus 1/2 sine 2 theta, and then it'd also be divided by 2 because that's what we'd get for the integral, and plus c. Yeah, because if we would just do the integral of cosine 2 theta, that would just be 1/2 sine 2 theta. And right here, that's why we divide by 2. And now we'll go ahead and bring everything down one last time. Cosine theta divided by 4 plus 3 over 8 theta minus 3 sine 2 theta all over 16, and then plus c because it's an indefinite integral with no bounds. And this right here is our final answer. If you guys have any questions, comments, or concerns, please leave it in the comments below. Thank you.